Am I Cool. All right. Ben Ryan, you can take it away. It's yours.
Hey everyone, how are you getting on? My name's Ryan, that's Ben, and today we'll be talking to you about the Agile and Cognitive Cloud Edge Continuum, or AC3. Don't ask what happened to AC1 or 2. Yeah, so to give a brief talk about the project, so we're part of the Horizon EU Research Grant, or also the IRIG team. That stands for the Ireland Research Interest Group. So we're part of one of 4 projects. AC3 is obviously one of the 4 projects. The others are Encode, Codeco, and Green Dot Dat. The project officially started, the AC3 project officially started in May 2023, and then the IRIG team formed in September 2023. So that's when we joined the project. Yeah, so to give you a few buzzwords before we get into the main stuff, I'd suppose Agile, which means the system that can adapt to changing conditions. Cognitive, which is the ability for the system to make well-informed decisions without human interaction. This is done through deep AI integration. And then Cloud Edge Continuum refers to the range of environment options the system leverages, from cloud data storages, data centers to IoT devices. And this is done on the far edge and everything in between. And then federated infrastructure. So that basically pools together resources across different environments for shared use.
Yeah, so what is AC3 then? So essentially it's a federated cloud edge infrastructure with deep AI integration. So the AI is managing resources across a network of different computing environments. So these can be in a platform agnostic way as possible. So these can be anything from cloud to edge to far edge devices, and it shouldn't matter whether the clusters installed on them are from different platforms. The federation layer should provide the interoperability. So it manages all aspects of an application's lifecycle. So this can be anything from retrieving or storing data to scaling or migrating microservices. And then the network is configured both proactively and reactively based on AI predictions. And the project has a big focus on green energy. So this could mean migrating microservices to the most green and efficient source of energy. So how do we know if we've actually achieved what the project is setting out to do? So the first thing is it'll manage both application life cycles and the actual infrastructure itself without any human input. It'll provide an integrated data management platform where developers can easily access their data. The federated model provides resource sharing, which enables stuff like distributed workloads. And then we have end-to-end network programmability. So the system is going to be able to onboard new environments, install clusters on them, and link them with other clusters. So zero-touch management is one of the key features of AC3, so I'll go over that, the components which make that possible. So the first one here is the AI-based LCM, which is the Lifecycle Manager. And it makes decisions based on a few other components input. So the first of these is the application profile. And this basically details all the important information about the application you're trying to deploy and its microservices. This could be anything from like application behavior, traffic trends, performance. And then we have similar profiles for the actual AC3 infrastructure itself. So this could detail things like network links or types of energy used. And then obviously we have real-time monitoring, which is constantly providing input about how the system is the microservices or the applications are actually performing in real time. And so with all of these coming together, the LCM can make well-informed decisions about the current and predicted state of the infrastructure and the applications that are running on it. So this is a high-level architecture diagram. So I'll quickly take you through it, and hopefully you'll have a better understanding of what the system actually looks like. So first we define the key performance indicators, and the ontology and semantic aware reasoner makes an application descriptor which helps the LCM with the initial deployment of the application on microservices. Then we move down to where the decisions are made. So again, this is the AI-based LCM, which is it's basically the brain of the system, and it's responsible for making all the decisions. So like I said, it uses the profiles and the monitoring to make the decisions, and then passes these decisions to the adaptation agents through the decision enforcement module. So the adaptation agents translate the requests for the infrastructure sites into instructions that the infrastructure can actually understand. And then the resource broker and discovery modules like allocating and exchanging information resources throughout the infrastructure. And then finally we have the actual infrastructure sites themselves, and this is where the microservices or applications are actually deployed. And throughout the whole process we have the data management platform up at the top right. And this basically just makes all the data that the applications needs available. So I pass you over to Ryan.
Yeah, so I'm just going to go over what Red Hat's role is in network programmability. Yeah, so basically AC3 passes its decisions and actions either through Kubernetes or SD1 using the local management systems through a northbound interface. Yeah, so these actions are initiated by the Kubernetes API on the federated control plane or by the SD1 controller. You can see there. These will just which in turn will just make changes to the network. And then this could be including creating or removing scupper routers or submariner gateways. This could be migrating application pods to another cluster or onboarded infrastructure site. Yeah, so we have multiple ways of connecting clusters. We can use Submariner, done through the OCM, or the Open Cluster Management System, like I said before, or a scupper link, or even an Istio mesh. And once these links have been set up, applications or microservices can be migrated by clusters based on the most efficient placement options. Yeah, so just to talk briefly about the network programmability tools, so the ones we're using right now. So Scupper, which creates a routing component from one namespace to another, which tunnels traffic. Submariner, which enables pods in different clusters to communicate with each other, rather at network level rather than application like Scupper. And then Netscaler acts as an application-specific traffic balancing method to distribute, optimize, and secure layer 4 to layer 7 network traffic. And then Everyone, which is an open source version of SD1, dynamically manages and optimizes network traffic, provides secure, reliable, and efficient connections between non-Kubernetes clusters, and fine-grained control over the network. Yeah, so OpenShift operators. So basically our goal is to build an OpenShift operator that will control the state of the clusters and be able to create or delete network links of the AI-based LCM. So we will use OCM to orchestrate multiple clusters across various networks, or various onboarded infrastructures. And then OCM also uses Submariner to link clusters by default, meaning our main concern is manipulating scupper links through CRDs.
Yeah, so one of the project's main use cases, which Red Hat is actually a lead of, is processing massive, and I mean like hundreds of terabytes of astronomy data. So this is produced by an observatory in Gran Canaria, and we're collaborating with the University of Madrid to basically figure out an efficient way of processing all this information. So the software that is being used by UCM is Starlight. And Starlight can be containerized as a microservice and deployed on the AC3 infrastructure. And the processing is going to happen in a distributed and parallelized way. So slices of a workload can be processed by different nodes on various sites, and the results are going to be stored and pieced back together on a shared volume. So this is kind of the architecture that we came up with to do that. So the main issue that UCM kind of faced on the technical side was actually processing all of this data efficiently. So Starlight accepts a large input file with massive amounts of parameters, processes it fairly slowly, and then the application stops and must be restarted with another big input file. So we wanted to improve that efficiency. and we didn't really want to have to dive into Starlight itself and start changing around codes, so we came up with this kind of simple producer consumer queue architecture model. So on the screen you can see that, and on the left here we have the producer pods. So we have one container in here, the event producer, which is basically looking at an input file, chunking it into events, and then publishing those events to the RabbitMQ you can see here. So each one of these little green chunks is an event which is being sent to a processing pod. And then in each processing pod we have two containers. We have an event receiver that is going to basically take in the chunks or events, write them into a file that Starlight can actually understand, and save that file to the shared volume. So then the Starlight container in the processing pod will take that file, process it, set a flag to say that it's actually processing something at the moment, it can't take any more. And then once it's finished processing, it'll remove the flag and store the results in here. Sorry, in here. And then once the whole workload is finished, it can all be pieced back together.
Yeah, so like we said, it's a new project, and we started back in May 2023. If you saw anything here today that might interest you, maybe technologies, or if you want to get involved in the project yourself, that'd be great. We're always taking on new partners. Yeah, and thank you. Any questions? That was great. So
One slightly side question. Since you mentioned it's from the telescope on the Canary Islands, do you remember exactly on which island the telescope was?
No, but I can tell you the.
Can you repeat the question for the recording, please?
So.
Oh yeah.
So, what the question was what do we know exactly what island the observatory is on? And I don't, but I know it's called Rock Le Dos Muchachos or something. The actual observatory itself. This is why I didn't include the name of it. Yeah, so I'm not sure exactly what island it is. I looked it up and it's at Gran Canaria, so that's the one I went for. Any other questions? Perfect. Thank you.